Okay, those who are online, am I audible? Am I audible to all of you? Those who are online, am I audible? Can you all hear me? Vishwajit? Can you all hear me? Yes, yes. শুনা গৈছে অডিঅ'টো আহিছে নে ঠিক আছে Okay, so good afternoon, all of you. I'll be doing this paper 3. Okay, we'll have another teacher who will be doing the maths part. I'll be explaining you the statistics. All right. So together we'll complete the paper. And it's just 2 months time or 2.5 months we have to complete the syllabus. I think you have heard of this paper 3. It's business mathematics and statistics. So whatever statistics portion is there, I'll be covering here. One more maths teacher will be covering the maths portion. And you have seen this topic, business mathematics and statistics. So all these, whatever statistics and mathematics we will have, all will be related to business only. So my portion starts with page number 235, okay, module 4. I can show you here, the portion which I will be doing here is this. Is it visible, those who are online? Once again, I'm asking the same. Okay, so this portion I am going to start with. Just a minute. Page number, what is the page number? 237. All right. So this is the introduction, but before that, once again, we will have these particular topics in module 4. So your statistics part starts with module 4, right? So statistical representation of data. And in each module, there are some sub-modules. Sub-modules means, suppose this is 4, chapter 4, okay? Then we'll have 4.1, 4.2 like this. So all these sub-modules we need to complete. Getting it? Now, introduction part, I have nothing more to explain, okay? Because if I keep on explaining the introduction, later part will run short of time. So introduction part, you have learned already in schooling. This is what is statistics. I just show it here once. Few just I have highlighted here. So what are statistics? What are data? Okay, just a minute. So statistics. Keep on looking this. You will go through this introduction part. How data are collected? What is the presentation of data? Presentation means we make table. Yes or no? Tabular form. We call it as telemarks table. Yes or no? Frequency distribution table. Analysis of data. Data can be analyzed. That means what? Data can be compared. Then interpretation. Interpretation part, I'll do some of the interpretation here. So data can be read out. So that is called interpretation. All these actually have done in schooling. Importance of statistics. Okay, what is the scope of learning statistics? Then statistics. What is the use of statistics in commerce? Okay, this one. Then these are the importance of this. Then limitation of statistics. So these are not that important for our exam. So introduction part, introduction page, you will go through once, getting it. So that few terms which are related to statistics, tabulation that I told you, collection of data, we can collect the data ourselves. Central tendency we will be doing, dispersion we will be doing, time series few will do, probably index number. So all these topics other than collection of data can be collected, by our own. Okay, or from some source. You can also Google it to get the data, right? So all this collection of data and all is not, very important for us. You have already learned, okay? But just here I want to tell you about this primary and secondary data because data so when something we collect in the form of numbers, that is a data. Suppose you all are here now in the class, your age, if I try to note down the ages of all the people here, okay, so this is a kind of data, right? So now this data, any data, or suppose the runs, made by Virat Kohli in the last World Cup, okay, 2024. So that data we may not know directly. We have to collect from some source. Maybe we Google it, or maybe from any other source. So when we collect data from source, that is secondary data. Okay, so it is written here already. Data when collected from some source. When the data is collected from source, this one. When data is collected from source, this is secondary data. When the data is collected by our own primary data. So as I told you, I'll be collecting the ages, your ages, or your weights. So if I collect by my own, this is primary data. If we collect it from some source, okay, Google or any other source, okay, then it is called secondary data, right? So this is how data can be classified, right? Then method of collecting primary data, you will go through this. As I told you, primary means we collect by our own. Secondary means we collect from source, okay, any source. Then requisition of good classification. How can this data be classified? So all these, the introduction topic only. So once again, I'm saying the same. You go through these once, okay. My actual portion starts with 4.1. All right. So I start with 4.1. This one. Diagrammatic representation of data, all right? So our statistics actually starts here, and I believe before you have taken the admission or during these classes you have come to know your question paper comes in the form of MCQ only, right? So, but statistics, it's not that MCQ that we will be, getting the answer without doing. Maths and this paper 3, you have to do and find the answer. Maths, you have to do the solutions. Statistics also, you need to go for the solution and then find the correct options. Getting it? So although MCQs, you should know the method. You should know the method, how the answer can be, obtained. So all these diagrammatic representation, I'll go through, I'll start it here right now. You will, whatever is here in the book, I'm not going to take it all these, line by line. I'll explain my own PPT or PDF, whatever I have, right? So because then you will have, you'll be learning from two sources. So you will learn from the book anyway, okay? If I explain from the PDF that I have made, okay? So it will be easy for you to learn from two sources. So textbook will go one by one. Whatever line chart is there, whatever the bar graph, etc. is there. So all this I'm going to explain from my PDF, okay? Now, this is what I'm going to start with, paper 3, section B, fundamental of business statistics. So my portion. Now, 4.1, as you have seen, this is 4.1, diagrammatic representation of data. Now, today's class will be limited again, that what you have learned in the previous classes, maybe in higher secondary classes or in up to 10. So you must have seen this line graph or line chart, or also we call line, line diagram. So what is that? You see just a minute, if it can be made larger. All right. So yeah. Now this is about line chart or line graph, or we call line diagram. So a line graph is a graphical representation of data in the form of lines, which displays changes of data continuously over a period of time. That means whatever data we have, what do you do? We represent them in the form of lines. We just make lines for the data to represent. And what actually it says, that line graph says the continuous changes of the data over a period of time. When time is changing, okay, what changes takes place in the data? So that is represented by line chart, right? Now, to make it, we take Cartesian axis. Cartesian axis means you must know x-axis and y-axis you used to take. Yes or no? So taking this point as O, and horizontal axis as x-axis, vertical as y-axis. So we take Cartesian axis to represent this diagrammatic representation for a line chart and all. Then along the abscissa, we take the independent variable. So, we represent some point here, right? Suppose we point is like 7,5. So this 7 is called abscissa, this 5 is called ordinate. Okay? So these points we keep on plotting. Now, while plotting, this 7 actually the value on x-axis. I hope you all know that. This 5 is the value on y-axis. So then in this point comes 7,5. This 7 x value, x coordinate, is called abscissa. 5, the y coordinate, is also called ordinate. Getting it? So it's written along the ordinate. And then all those points, whatever we'll get it, all the points, whatever we'll get it, we join them by line. That is only the line graph. Okay? So we join the points with the help of lines. So we call it as a line graph. Not very difficult, nothing, I don't think that you do not know all this topic. So this is the first example how a line graph works. Suppose these are the temperature changes at some particular time, 6 a.m., 10 a.m., 2 p.m. and 6 p.m. So 6 a.m. it becomes suppose 37, then 10 a.m. 40 degrees Celsius, 2 p.m. 38, and 6 p.m. suppose 35 degrees Celsius. Now to make this line graph, you all know what you need to do is along the, just a minute. So what you need to do is along the x-axis, this is the x-axis here, 6 a.m., 10 a.m., 2 p.m. and 6 p.m. is drawn. Then these are the temperatures. So 6 a.m. 30, I think 7 it was. So 10 a.m. 40, then 2 p.m. it is 38, and 6 p.m. it is suppose 37. Just to make the join the those points that we obtain after plotting these points. So this is with the help of line. So this is a line graph. Getting it? Is it okay? Did you notice before? Yes, of course you should know this. Yes or no? So then line graph can be 2 also, okay? Or from line graph, for line 2 line graphs can also be together done. This is a dual or double line graph. So you see, I'll come to the question. This is what the line graph here is. Okay. Now you must have seen here right now that there are 2 line graphs. Okay. This data analysis is about the performance of 2 batsmen, batsman A and batsman B. Now, batsman A, whatever his performance is, it is written, explained, or drawn by dotted line. Can you see that? I think you have done this type of questions. Batsman B, so his performance is drawn with the help of continued line, right? Now, I said we'll be discussing few things like interpretation. Now, what is this interpretation of graph? So, interpretation of line graph means a situation is given, a graph is given. From the you are not asked to draw the graph. What will be asked? You have to answer the questions. Seeing the graph, you need to answer the questions. That is called interpretation. All right. So interpretation of graph. That means from the graph we have to give the correct information. So supposing, okay, let me read the question. Then you will understand 1 or 2 questions if I do. The given graph represents the total runs scored by 2 batsmen A and B. I just read out the question. Okay? So as I told you, these are performances of 2 batsmen A and B. Now, during each of 10 different matches in the year 2007, so they played 10 matches in the year 2007. So that is what is drawn on the graph. Study the graph and answer the following questions. Okay? So the first question, suppose what information is given on the 2-axis. What information is given on the 2-axis. So, if I show on the 2-axis means x-axis and y-axis, yes or no? So, this is your x-axis and this is your y-axis. So, x-axis, what the information is given? The information is given how many matches they played. So, information on x-axis is the number of matches played by them, yes or no? Information on y-axis, what is that? The runs scored by both the players. Okay, so that is the first answer. Now, so what you have done here, we did not draw the graph. Just seeing the graph, we are trying to answer the questions. That is called interpretation. Which line shows the runs scored by batsman A? Very easy. Batsman A, the dotted line shows that. Okay, where the runs scored by them same in any match in 2007. In the year 2007. These are the representation of their performance. The question is, in any match, did they score the same? If so, in which match. So what is that? If they have scored the same score in one of the matches, you have to find out where and in which match. So it may be more than even one. So for that, what you have to see, the point where they meet on the graph, both the lines where they meet on the graph, just you have to see that only. So for example, I can see here this point, yes or no, where both the graphs meets. That means both the batsmen made equal score. So how much they made? 60. In which match? Fourth match. Fourth match, batsman A and batsman B, they made equal scores. Can I have some more? No, I think. Yes or no? So this is only the match where the two batsmen made the equal scores. Okay. Similarly, the other question. Among, okay, let me even read out the last one, number 4 actually, that one. Among the two batsmen, who is steadier? How do you judge it? Who is steadier means, I give an example. So, suppose batsman A, okay, he scored suppose 50, then 40, then 35, then suppose 55, then suppose 30 like this, okay. Batsman B, he suppose scored 100 in the first match, then 10, yes or no? Then suppose he scored 19, then again suppose he scored 75, okay. Again he scored 40. Who is steadier? A. Because constantly he is making almost the same performance. But this batsman, sometimes 100, sometimes 10, sometimes 0, yes or no? So he is not steadier. And while selecting, for the team, the selectors used to prefer this type of people like A, not people like, because they cannot predict on this, they cannot have, fate on these people, because they might even score 0, right? So that is what's steadier. Now, how to read it from the graph? How to understand it from the graph? So it is easy. Who is constantly performing almost the same or above a benchmark? Benchmark means like 30. Every time he is scoring above 30, that 30 is the benchmark. Okay, pass mark, the way we have the pass mark. Now, if I talk about batsman A, you see he scored this one 115 in one of the matches. But in this third match, he scored how much? 0. But look at the other player, that is batsman B. Every time he is scoring 40 and above. Have you seen this one? Okay, so every time he is scoring what? 40 and above. Okay, so he did not score even 100 plus. But he is steady because he is performing almost the same. That is what called steadier. Now, why this type of questions to be done? Because as you know, your paper is MCQ, questions will not be asked to draw the way you have drawn in school, right? So, in that case, you should know how to read the graph. Getting it? So it's an easy reading, the first chapter only. So second one is also same. I'm not going to do again. It's just we have to see the graph and get the details. Getting it? If required, I'll send the PDF. Right? Now, coming to linear graph and line graph. So look at this. One of the question I have given, is it a linear graph? So a line graph, okay, and a linear graph. What are those, and if they have any difference? Getting it? Line graph and linear graph. Right. Now, line graph, just now what we have discussed. This is your x-axis, this is your y-axis. Okay. So we got a point here, suppose, just a minute. We got a second point, suppose here, the third one here, fourth one here, fifth one here. Then we join them in order. Okay. So this is a line graph because it is a combination of lines. Right? Now, this line graph only, if I suppose get it in a slightly different way. For example, this is your O origin, as you already know. Yes or no? Now, suppose if I get the points here like this, first point, then second point, third point, fourth point, fifth point. If I join it, it is again combination of what? Lines. So this is also a line graph, but linear. Linear means it is straight. Getting it? So, all line graphs are linear graphs. Sorry. All line graphs are not linear, but all linear graphs are, because in all linear graphs, lines are there. Lines are there means only a line graph. But this is not linear, as it is not straight. So what is that? Line graphs, all line graphs, for example this, all line graphs are not linear, but all linear graphs are line because they are a combination of, okay? So this is what line graph and linear graph. So we can, this is a question, suppose we'll be plotting them and we see whether we get a straight line or not. If you get a straight line, linear graph. If not, not a straight, it is not a linear graph. So plotting, I think you have done before, yes or no? Yes or no? In school? All right. Now, coming to the next topic, this is bar graph. These are very, easy and common topics. So that's why I'm trying to go fast because we have little difficult topics as well later. Now, bar graph, I think you also know about bar graph. Yes or no? So bar graph actually, basically we represent, bar graph basically we represent when the data cannot be clubbed, cannot be combined. Suppose these are, I think, once again some marks or points scored by some teams. So team A is different from team 2. Team 2 is different from team 3. So when you plot them, okay, when you plot them, their bars will be individual bars. Individual means what? Different bars. They will not have the same bars. Getting it? So in that type of representation where the bars are different, separate from each other, but they have a common or uniform gap. Look at the gap. Gap is same. Gap is same between them. Okay? This is what a bar graph is. And just if I read out the definition, a bar graph is a graphical representation of data which consists of a number of bars. Bars means actually rectangles of uniform width. Uniform width means their sizes are same. You should not draw one bigger, one smaller. Okay? With equal spacing between them. Between them, space is equal. Space is same. Right? Now, the height, that means for the vertical bars, how much they are taller. The height depends on the value that they represent. So what value they represent, on that only they will go. Suppose team 2 scored 36. So it will go up to 36, it cannot go to 56. Right? So what value they represent, on that only what? The bar goes up to that length. Right? So this is the first one, simple bar graph. Simple. Individual bars we draw. But I'm going to show it now few more bar graphs which you did not, I think, come across, okay, before. And it is there. So I think this also you have come to know. I'm going to show you in your paper also. I just show it which bar graph actually I'm talking about. There are some bar graphs, these all. Simple bar graph, this is what I have explained just now. You know from schooling, simple bar graph. Multiple or group bar graph, you know this. Subdivided, I'm not sure you know or not. Percentage subdivided. Deviation or, broken bars. All these last few topics I think you did not get in school. So, I'm going to show it one by one. The first one is shown. Now, multiple or group bar graph. I think you have learned it in the school life about these bars as double bar graph. I think you have learned it like double bar graph. So, what happens here? We the data we represent dual in dual. Dual means what? Two bars together. Now, if I try to explain this, look at this situation. Okay, look at the question. Following bar graph shows the marks obtained by a student in 2005, 2006, and again in 2006, 2007, subject-wise. Now read the answer and read the questions and answer the following questions. Now, if you observe this, student is the same student. He has the same subject, but in 2 different years. That is why the subject is keeping the subject same, the bars are drawn together, and one bar is suppose from 2005 and 2006, other one is for 2006 and 2007, and they have even shaded also. This shaded one is for the next year, 2006-07. Unshaded one is, 2005, 2000. So, here even one more year if comes, 2007 and 2008, we can add one more bar here. Then it will not be double, it will be triple bar graph. So, even more than that if we have multiple, more than 2, 3. Okay? So, this is actually the benefit of drawing bar graphs like this is, we can compare very easily. Suppose, if I ask you now, in which year the student performance is better in maths? So, in which year he performed better? That's 2006-07. So, comparison can take place easily. That is why. In which year the student performed the same? Which subject? Hindi. So, comparison becomes easier when you draw multiple bar graphs. Done? So this is multiple or double bar graph. So you know this, right? Now coming to this subdivided, is there in your module as well? Subdivided or component bar graph. Not difficult, but maybe unseen. Okay? I think you do not know the term, but it is not at all difficult. See what? Let me read the question. Subdivided or component bar graph. So what comes in exam, in your exams? This type of one, bar graph will be drawn, questions will be asked from there. Getting it? Look at this. One example. During 1968 to 71, during these years, 3 years, the number of students in university, suppose X, are as follows. Represent this data by a similar diagram. Actually, I picked up the question from somewhere. Similar means they're talking about the component bar graph. Now, to understand that, first of all, you have to understand the data. In 1968 to 69, in arts, 20,000 students, science, 10,000 students, law, 5,000 students, and as a whole, total 35,000 students. Now, when we, this is in which year? 1968 to 1969. Yes or no? Now, what we do is, subjects are different, but the year is same, or the session is same. So, although the subject is different, and the year is, since the year is same, what we do here is, for each year, 2 or 3 subjects, we mark them together. So, look at this, 1968 to 69, this is the year in which arts, there were 20,000 students, science, okay, how many? 10,000. 10,000 means 20,000 plus, right? 10,000, so it will go up to which? 30,000. Then in law, what? 5,000 more, so 30 to 35,000. Have you seen this? So this bar graph is a combination of three portions. One is for arts, then science and law. But actually it is same for the year or for the session 1968 to 69, but it is divided into subparts: arts, science, and laws. So when you make some division like that in the same graph, and of course we should shade them differently. Shade them differently because otherwise they will mean the same. So arts, no shading. Science, suppose green, and law, suppose it's blue. So based on this, you have to answer the questions. Okay, it is drawn, but based on this also, you will be asked to answer the questions. And in a similar way, suppose if I explain for 1970 to 71, arts 31,000 students here. So sometimes this table is not given. This table is not given. The graph is given. Question is asked. Suppose if I ask the question, don't look at there. You try to answer from here. In 1970 to 71, how many students were there who studied science? Answer. This one. I'm talking about this. In 1970 to 71, how many students were there who studied science? So what is that? What is that? This is from which number? 31,000. Okay, it's not very clear, but there it comes, it will be clear. So from 31 to this portion, total length you have to find out. Getting it? And then, so it is suppose here 40. From 40, it is suppose here 31. So this minus this portion from 40, this will be the required number. Is it clear? Okay, so like that, we can get the answers from component bar graph as well. Now, if I come to percentage subdivided bar graph, it is the same thing that you have done just now, but here it will be mentioned in terms of percentage. That is what? So last time, direct number. Sorry, just a minute. So here in this, we had direct numbers, but now instead of direct numbers, we can also have what? Percentage. So this is another example. The percentage subdivided bar graph. Suppose these are a percentage of some sales in a in any suppose organization or any institution. Okay, so cooler is sold 12. This is not the number. I think it is a percentage, 12% in May. Then AC 32%, not 32 number, 32%. So refrigerator 36%, then total sale is 80%. So what you have to do is to go to the month, then just you see this percentage. This is the percentage for what? The in the month of May, the percentage of sale for cooler. Getting it? So like that, we can have question. Now, even if it may come like this, if just one question based on this, what type of questions might ask from here? The question, one question is suppose there, if the total sale, just a question, if the total sale in May, in the month of May, is suppose rupees 4 lakhs, then the question is suppose what was the total amount, okay, what is the total amount earned, what is the total amount earned after selling suppose AC, right? So if the total sale in the month of May, total sale means what? Sale of all these three, okay? This, and this. So if their total sale is, sale of this means what? Sale of the cooler, sale of AC, sale of refrigerator. So if their selling is total 4 lakhs rupees, how much money was earned after selling AC? It's a very easy one. It's a concept of percentage only. AC, this is what the percentage for AC is. What it will be? 32. Yes or no? So what you have to do? Just 32% of that 4 lakhs. 32% of 4 lakhs. Okay? I hope you all know to find out. 32 out of what? 100. Am I correct? So it is 4 lakhs. Just cancel the zeros. So multiply this number. This is 128. Then 0, 0, 0. So 1,28,000 rupees. So my aim is not to explain all this. My aim is to explain what type of question can be asked in the exam. Right? So you can easily find out. You just see the percentage, get the solution by converting them into the, so it is given in percentage. Total sale is suppose this. You can get it easily. The total amount that is earned by selling this particular item is C. Done. So this is about percentage subdivided bar graphs. So in the bar graphs can be divided in percentage as well. Done. Now, look at this. Deviation or bilateral bar graph. So it is also not a difficult one, but maybe unseen. Maybe you have not seen it before, but not at all difficult. So here, look at this. It is a deviation. Suppose, for example, deviation means what? Difference. So what difference occurs here? Sometimes the sale goes up, profit earned. Sometimes the sale gone down. I think you are doing in commerce. Okay. So when the profit goes, when the sale goes up, more money is earned. There is a profit. Sale goes down, money earned less. Okay. It goes beyond the cost price. Then loss occurs. So when this type of data we need to represent on graph like this, getting it? So a graph comes like this, where the sale, whatever is there, sale and the profit, sale and the profit. So we plot, this is about sale and profit. Now if I show it here one, you see the first one, in the year 1985 to 86, this one, 1985 to 1986, the total sale is 10%. Total how much sale? 10%. 10% is the sale. Right. Look at this. So 10% is the sale. Just a minute. Just 1 minute. Okay. So now, so 10% was the sale in 1986 to 85 to 86. 10% was the sale. From that sale, profit earned is 50%. Getting it? That means huge profit is earned. Now when, so this first pink graph, whatever is drawn, that bar shows the sale. So this pink color one is the sale. It's right. It's written also here. Then the profit, whatever profit is earned, that is shown by suppose the blue, the purple color, right? So now 10% is the profit. 10% is the sale. Profit earned is 50%. So this is the graph. But the second one you see. And that is for the year 1985 to 86, together they are drawn, like a double bar graph. But okay, then there is a gap. There is a gap between them because the years are different. Now 86 to 87, you see the sale is suppose 14%, but this time there is a loss. How did I know loss? Because minus 20%. Minus 20% means the loss is negative, right? So since it is loss, I think you have understood. Since it is loss, it will go below 0. So actually, here it will, sorry, just a minute. So actually, this is your x, this is your y, right? So 10, 20, 30, here it will come, minus 10, minus 20. This line I just, okay? So minus 10, minus 20, minus 30 like that. So when there is a loss, negative. Okay? Similarly, there are also a loss in the third one. So loss is shown in the negative. Okay? So this is deviation. Deviation means sometimes there is a profit, sometimes there is a loss. Both the data are together there. So it is a deviation. Right? Broken bar graph. Term-wise, you may not know, so I am showing it. You look at this graph and tell me why this type of graphs are required. Broken bar graph. Look at this graph and tell why broken bar graphs are required. Okay, say. Limits are? Okay, so I give an example to understand this, right? Suppose you have invested some money in the share market, suppose. So the first, okay, I give an example. So suppose you have invested rupees 1 lakh in share market, right? First month, suppose you did not get any profit, example. Then suppose you earn 250 rupees profit. Next month, suppose you have earned 500 rupees profit. Next month, you have suppose earned 750 rupees profit. Next month, suppose you have earned 1,000 rupees profit. So profits are increasing. But suddenly, the share rose up. Okay, share is rising up. Then suppose you earn 35,000 profit. Is not it a very huge gap between them? So when there is a huge gap between two datas, now from 10,000 to 35,000, can we plot it here? Not possible. Because we are doing like 0, 250, all are increasing by 250, 250, 250, up to here 250 gap. But after 1,000, there is a sudden increase. From 1,000 to 35,000, 34,000 increase is there. So if I plot, next one is 1,250, 1,500, will it be meaningful? It will be too long. It's may not be possible to make it, right? So in that case, when there is a huge jump, in the data, okay? So from 1,000 direct, there is a jump to what? 35,000. Huge jump when occurs, getting it? Then we use this type of broken line, getting it? To mention or to show that we have not written all the data, we have not listed down all the data. Actually, it's not possible. So in that case, the broken bar graph is required. So this broken bar graph is used here. Getting it? So like that, we can use broken bar graph to show that there is a jump in the data. Getting it? That means this data we are not plotting on the bar graph. Getting it? Now, another broken bar graph is there. You see, this is 500, 1,000, 1,500. They're increasing by 500, 500 up to this. But after 1,500, directly how much? 75,000, right? Huge jump or not? So in that case of huge jump, okay, we skip the data writing, and then we have to use this broken line. Sometimes people used to, use the broken line this way also. Mainly in foreign countries, they don't use the way we use. We used to use like this. Okay, we used to use the broken line like this, right, or like this. But somewhere people use this type of broken line also. Getting it? Then now coming to pie chart. Okay, this is again a graphical representation of data. We are going to start a question on this pie chart. Now look at this. Just a minute. Okay. So pie chart, another name is circle graph, another name is pie diagram, another name is angle diagram. So how to draw doesn't come. The diagrams doesn't come. Question comes from this. Getting it? So, a circle graph, I think you have got it before. I don't know how did you name it. There are 4 different names, or even more than that. Pie chart we used to call circle graph, pie diagram, etc. Now, here a pie diagram is a circular graphical representation. We draw in circle, okay, which represent the total value with its components. So they represent actually the total value. Done. Now the circle is divided into sectors. I think you know what are sectors. Sectors are like this. Suppose this is a circle, this is a sector. Sector means the portion bounded by what? 2 radius, okay, 2 radii and 1 arc. So this is called a sector. So in circle graph, we show them in sectors, right? Now, the area of the sector is proportional to the angle they represent. I'm going to show it how to get the angles. In which the area of the circle represents is the total value, and the different sectors of the circle represent different parts. So, for example, look at this circle graph here. We have 1, 2, 3, 4, 5 different subjects, and their angles are drawn. Their angles are drawn 144, 36, 72, etc. Now, I asked a question: which is the subject where suppose these are the performance of one student. If I ask a question, which subject the student performance is the best? Just you see the numbers, see the angles, where 145 is the highest, so in maths, least, lowest performance, science, right? Now, if I ask a question based on this, suppose if the total marks was, try to answer, if the total marks was 720, okay, how much the student, okay, how much the student scored, in science? It's a question, suppose. Can you answer? Question is, this is the pie chart. Based on this, we are going to write an answer. MCQ comes, then your options will be given: option A, option B, option C, option D. So, okay, you have to solve it and get the answer. My question is, once again I repeat, if the student total marks is 720, this pie chart is all about the performance of a student who appeared the exam out of 720. Then, or how much he scored in science? How much? What is the angle measurement for science? 36 degree. Can you say 36 out of how much? Fractional form, fractions concept. Do you know this is science? Yes or no? This is the science portion. 36 out of total. Can you say what is the total angle? 360 degree. Done no? So this science covered only 36 degree out of 360 degree multiplied by that total marks he got. How much? 720, right? So cancel the zeros. 36, 36 direct cancel. How much he got? So like this, okay? So here options will be there. You have to write the correct option. Got it? Now, so one similar question was there that I gave it. I asked a different one. Example 2. On a particular day, the sales of different items of a baker's shop, bakery, that means we say bakery, okay, are given below. So these are items and their sale. Bread suppose sold for 320 rupees, biscuits for 120, cake for 160, sweets 80, and other some items like 40 rupees. Now the question is, find the central angle. You know what is the central angle? The angle they represent. Suppose maths, what is the central angle? Central angle means the angle represented at the center. So maths, for maths, the angle made at the center is how much? 140. So that is the central angle, right? So the question is, we are asked to make central angles. Actually, if we make central angle, then only you can draw that, right? So in this example, the question is, find the central angle for each sector representing the above item, and hence draw a pie chart. We are asked to draw the pie chart, but before that, we have to make the central angles. okay, from this data. Getting it? So I'm going to do it, and this will be the last question for today. So what you're going to do is, we'll make this table once again there. Okay? You do one thing, write the question. Everybody write the question. Write the question first. We'll make the central angles, and I'll explain how a pie chart can be drawn. Is it okay? Those who are online, can you all hear me? Write a question. So the question is, find the central angle, and then you have to draw the pie chart. Pie chart is just the angle you need to measure and get the diagram. Okay? Can I start? Is it done? Okay. So what you need to do is, these things we have to make again. So these things you have to make once again here in the answer. So items and cells, and then direct central angle. Okay. So this is the answer that I'm going to do here. You write it here. Okay, I can directly do there in the right. So how it was? It was items. Yes or no? It was items. Okay, it was written here items. Say what next? Cell, right? Cell in rupees. Cell in rupees. And we are asked to find the central angle. Central angle is the angle that each of these items represents at the center of the circle. So central angle. Getting it? So let's try. Now, please tell me, the first one is bread, I think. Yes or no? I think it was 320 rupees. Correct? Second one? Biscuits. How much? 120 rupees. Third? Cake. How much? 160 rupees. And sweets. How much it was? 80. And I think others? Yes. Others is 40 rupees. So this is the table. Now to make the central angle, it's very easy actually. You have to get the total of this. You have to get the total of all these items at this 320. How much? 720. Example is, I'm taking easy example so that everybody understand. Now central angle. To get the central angle one by one, you have to do it. Bread. Bread, the total sale is 320 rupees. Out of, for bread 320 rupees, out of total sale how much? 720. So this is like 720. Now, central angle means in the circle how much angle they make. Total angle is how much? So out of 360, how much portion it covers? That is actually the central angle. So that is why to get the central angle, out of the total angle how much? So we have to multiply. This is what the simple method is. What you have to do is, the sale is 320, out of total sale, how much? 720, need to multiply by 360 every time. Why 360? Because out of that 360 degree here, bread covers how much angle? That is the central angle, right? So if you do it now, direct, 2 times, okay? By 2 if you get 160 degree, right? Say next, biscuits, what it will be? 120 out of 720 multiplied by 360 degree. 362, how much will be? 60? Okay. Then this is 80 out of, keep saying, 80 out of? 80 out of, 80, sorry. Cake, 160, okay. 160 out of 160 out of 720 to be multiplied by how much? 360 degree. Directly, if you cancel 2 times, how much? 80 degree? Yes or no? So then this 80 out of 720 multiplied by 360, if you cancel it, 2, so 40 degree. And finally, this is 40 rupees sell only out of 720 rupees multiplied by 360. So if you cancel 2, how much it will be? 20 degree. Now, how to know, how to check that you have done a wrong table or correct table? How to know these answers are correct or not? Yes. Just you add these numbers, they must be, okay, if not, then wrong somewhere. So we can check it, 80 plus 20, 100, 40 plus 60, 100, 200, 200 plus 360, 160 is, so table is correct. Now, everything is ready. Plottings, basically, we don't have, actually it doesn't come, but anyway, if I now try to draw it, so what you have to do is, table is ready, so you have to just go to a circle, then you go it here, suppose. Now, the first angle is, how much? 160, you have to construct an angle 160 here, using protractor. So, as I told you, it's not that important for us. So, 160 is the angle for which item? Bread, yes or no? So, you can put different patterns or different colors. So, this is for the first item. Then, what? 60 for biscuits. So, 60 degree, but be very careful, here itself, 60 degree, okay, for next item. Then next one is, whatever, 120 or whatever, we'll make it next item and so on. So, this is how we can get the pie chart. Done? So, constructions or drawing is not, it doesn't come directly, but question comes based on those diagrams. All right. So, with this, if you see the model once again, can you tell me the page number? So, we are doing 4.1. So, with this, 4.1 is over. You see the bar, pie chart, angle diagram, everything. So, this is the last one of this. So, I completed 4.1 with this pie chart. Have you seen? This is the last one. Done. So, tomorrow means in my next class, we'll be starting the 4.2. All right. Okay then. Thank you. Thanks.